Materials used in spacecraft. Spacecraft are designed to operate in the extreme conditions of space, including high temperatures, intense radiation, and vacuum. Therefore, materials used in spacecraft must be strong, durable, and capable of withstanding the harsh space environment. In this article, we will discuss some of the materials commonly used in spacecraft. Aluminum. Aluminum is a lightweight metal that is widely used in spacecraft construction. It is known for its strength, durability, and resistance to corrosion. Aluminum alloys are used in the construction of the spacecraft structure, as well as in various components such as fuel tanks, rocket boosters, and satellite frames. Titanium. Titanium is a strong and lightweight metal that is commonly used in spacecraft construction. It is known for its high strength-to-weight ratio and resistance to corrosion. Titanium is used in various components of spacecraft, including the spacecraft structure, rocket engines, and heat shields. Carbon fiber. Carbon fiber is a lightweight and strong material that is commonly used in spacecraft construction. It is made by weaving together carbon fibers into a fabric, which is then coated with a resin to create a strong and durable material. Carbon fiber is used in various components of spacecraft, including the spacecraft structure, solar panels, and antenna reflectors. Ceramic. Ceramic materials are known for their ability to withstand high temperatures and intense radiation. They are commonly used in spacecraft heat shields, which protect the spacecraft from the extreme heat generated during re-entry into the Earth's atmosphere. Ceramic tiles are also used to protect the spacecraft from the intense heat generated by rocket engines during launch. Kevlar. Kevlar is a strong and lightweight material that is commonly used in spacecraft construction. It is known for its high tensile strength and resistance to impact and abrasion. Kevlar is used in various components of spacecraft, including the spacecraft structure, parachutes, and spacesuits. Stainless steel. Stainless steel is a strong and corrosion-resistant metal that is commonly used in spacecraft construction. It is used in various components of spacecraft, including the spacecraft structure, fuel tanks, and rocket engines. Stainless steel is also used in the construction of the nozzle of rocket engines, which is exposed to extremely high temperatures during operation. Tungsten. Tungsten is a dense and strong metal that is commonly used in spacecraft construction. It is used in the construction of radiation shielding, which protects astronauts and sensitive equipment from the harmful effects of cosmic radiation. Tungsten is also used in the construction of the filaments in light bulbs, which are used in space to provide lighting. Beryllium. Beryllium is a lightweight and strong metal that is commonly used in spacecraft construction. It is used in the construction of X-ray telescopes, which are used to study the universe in the X-ray spectrum. Beryllium is also used in the construction of nuclear reactors, which are used to power spacecraft on long-duration missions. Glass. Glass is a versatile material that is commonly used in spacecraft construction. It is used in the construction of windows, which provide astronauts with a view of space. Glass is also used in the construction of optical instruments, such as telescopes and cameras, which are used to study the universe. Silicon. Silicon is a versatile material that is commonly used in spacecraft construction. It is used in the construction of solar cells, which are used to generate electricity from sunlight. Silicon is also used in the construction of computer chips, which are used to control spacecraft and perform scientific experiments. Inconel. Inconel is a family of nickel-chromium superalloys that are known for their high strength and resistance to corrosion and heat. It is commonly used in spacecraft construction for components that require high strength and durability, such as rocket engine parts and heat exchangers. Mylar. Mylar is a type of polyester film that is commonly used in spacecraft construction. It is used in the construction of thermal blankets, which provide insulation to spacecraft and protect them from extreme temperatures. Mylar is also used in the construction of solar sails, which use the pressure of sunlight to propel the spacecraft. Zirconia. Zirconia is a ceramic material that is known for its high strength and resistance to wear and corrosion. It is commonly used in spacecraft construction for components that require high strength and durability, such as bearings and electrical insulators. Graphene. Graphene is a material made of carbon atoms arranged in a hexagonal lattice. It is known for its high strength, flexibility, and electrical conductivity. Graphene is being researched for potential applications in spacecraft construction, such as in the construction of lightweight and strong components. Teflon. Teflon is a synthetic fluoropolymer that is known for its non-stick and heat-resistant properties. It is commonly used in spacecraft construction for components that require low friction and high heat resistance, such as bearings and seals. Epoxy resin. Epoxy resin is a versatile material that is commonly used in spacecraft construction. It is used as an adhesive to bond components together and as a coating to protect surfaces from wear and corrosion. Epoxy resin is also used in the construction of composite materials, such as carbon fiber composites. Aerogel. Aerogel is a lightweight and highly porous material that is known for its low density and high thermal insulation properties. It is used in spacecraft construction for insulation, as it can withstand high temperatures and provides excellent thermal protection. Copper. Copper is a highly conductive metal that is commonly used in spacecraft construction. It is used in electrical wiring and components, such as power distribution units and sensors. Copper is also used in heat sinks and thermal management systems, which help to regulate the temperature of spacecraft components. Gold. Gold is a highly reflective and corrosion-resistant metal that is commonly used in spacecraft construction. It is used in the construction of mirrors and reflective surfaces, which are used in optical instruments such as telescopes and cameras. Gold is also used in electrical contacts, which provide a reliable and low-resistance connection between components. Nickel. Nickel is a strong and corrosion-resistant metal that is commonly used in spacecraft construction. It is used in the construction of rocket engines, fuel cells, and electrical contacts. Nickel is also used in the construction of magnetic components, such as electromagnets and magnetic bearings. The synchronization of objects in the universe is a fascinating topic that has intrigued scientists and astronomers for centuries. From the movements of the planets in our own solar system to the behavior of galaxies in the far reaches of space, The universe seems to operate with a remarkable degree of coordination and synchronicity. One of the most striking examples of this synchronization is the way in which the planets in our solar system move in relation to each other. The orbits of the planets around the Sun are not only predictable, but they are also synchronized in a way that allows us to make accurate predictions about their positions and movements. This synchronization is due to the gravitational forces that exist between the planets and the Sun, which act to keep the planets in their respective orbits. Beyond our own solar system, there are other examples of synchronization in the universe. For example, binary star systems, in which two stars orbit around a common center of mass, are often found to be in a state of synchronization known as tidal locking. This means that the same side of each star always faces the other, as a result of the gravitational forces between them. Similarly, some moons in our own solar system are also tidally locked to their parent planets, meaning that they always show the same face to their planet. On a larger scale, galaxies themselves appear to be synchronized in their movements. Galaxies often exist in clusters, and the motion of these clusters is not random, but rather is coordinated in a way that suggests a larger pattern or structure. This coordination is believed to be due to the gravitational forces that exist between the galaxies in the cluster. The phenomenon of synchronization in the universe is not limited to the movement of objects, however. There are also examples of synchronization in the behavior of other physical systems, such as oscillators. For example, many pulsars, which are rapidly spinning neutron stars, emit radio waves that are incredibly regular and precise. This regularity is thought to be due to the synchronization of the oscillations of the pulsar's magnetic field. One of the most interesting aspects of synchronization in the universe is how it relates to the concept of time. The regularity of the movements of planets, stars, and other celestial objects has allowed us to develop precise methods for measuring time and keeping accurate calendars. For example, our modern calendar is based on the movement of the Earth around the Sun, with a year defined as the time it takes for the Earth to complete one orbit. The synchronization of objects in the universe is also relevant to our understanding of the history and evolution of the cosmos. By studying the motions and positions of celestial objects, astronomers can infer information about the past and predict future events. For example, the study of the motion of galaxies has led to the discovery of dark matter, a mysterious substance that is believed to make up a significant portion of the matter in the universe. In addition, the phenomenon of synchronization in the universe has practical applications in fields such as navigation and communication. GPS technology, for example, relies on the synchronization of signals from multiple satellites in order to determine the location of a receiver on Earth. Despite the many examples of synchronization in the universe, there are still many mysteries to be uncovered. For example, scientists are still working to understand the precise mechanisms behind the synchronization of binary star systems and the regularity of pulsar emissions. In addition, there is much to be learned about the larger structures and patterns that exist in the universe, such as the distribution of galaxies and the nature of dark matter and dark energy. Moreover, the concept of synchronization in the universe has also inspired philosophical and spiritual reflections. The idea that everything in the universe is interconnected and operates in a synchronized manner has led to a sense of wonder and awe among many people. Some have even described this interconnectedness as a kind of cosmic harmony or unity. This sense of cosmic harmony has also been reflected in cultural and artistic expressions throughout human history. For example, ancient cultures, such as the Mayans and Egyptians, developed complex calendars based on the movements of the sun, moon, and planets. In addition, many works of art and literature have been inspired by the beauty and mystery of the universe, From Vincent van Gogh's Starry Night to Carl Sagan's Cosmos. The study of synchronization in the universe is an ongoing and dynamic field of research. With advances in technology and new discoveries, our understanding of this phenomenon is sure to deepen and evolve. One area of particular interest is the study of gravitational waves, which are ripples in spacetime caused by the movement of massive objects. The detection of gravitational waves in 2015 opened up a new window for studying the universe and its synchronization. The synchronization of objects in the universe is a fascinating and intricate phenomenon that has captivated the attention of scientists and researchers for centuries. From the orbits of planets to the rotation of stars and galaxies, the movements of celestial objects are all part of a grand symphony that plays out in the vast expanse of space. One of the most striking examples of synchronization in the universe is the relationship between the Moon and the Earth. As the Moon orbits the Earth, its gravitational pull causes tides to rise and fall, creating a rhythmic pattern that repeats itself with clockwork precision. This synchronization is so precise that the Moon's orbit has been used to measure time for centuries. Another example of synchronization in the universe is the rotation of planets. Planets like Earth and Mars rotate on their axis, completing one full rotation in a 24-hour period. This rotation is synchronized with the planet's orbit around the Sun, creating a regular cycle of day and night that is essential to life on Earth. The synchronization of stars is also a fascinating area of study for astronomers. In binary star systems, two stars orbit around each other in a synchronized pattern, their movements influencing one another in a complex dance that can last for millions of years. This synchronization can even lead to the creation of beautiful phenomena like supernovas and black holes. At the largest scale, the synchronization of galaxies is a subject of ongoing research for astrophysicists. Galaxies are thought to be synchronized by the gravitational forces that exist between them, with larger galaxies influencing the movements of smaller ones. This synchronization can lead to the creation of galaxy clusters and superclusters, massive structures that can contain billions of galaxies. Despite the complexity of these synchronized movements, they are all governed by the same laws of physics that apply throughout the universe. By studying these phenomena, scientists hope to gain a deeper understanding of the underlying principles that govern the behavior of matter and energy in the universe. Furthermore, the study of synchronization in the universe has practical applications as well. For example, the synchronization of GPS satellites is crucial for accurate global positioning and navigation. These satellites orbit the Earth at a precise distance and speed, allowing them to maintain a synchronized system that provides accurate information to GPS devices on Earth. In addition, the synchronization of objects in the universe has implications for the search for extraterrestrial life. The search for life on other planets is based on the assumption that life requires certain conditions, such as the presence of water and a stable environment. Synchronization of celestial bodies plays a crucial role in creating these conditions, such as the stable climate on Earth created by the synchronization of its rotation and orbit.
The formation and evolution of the universe. The universe is an ever-expanding entity that has fascinated humans since the dawn of time. From the Big Bang to the formation of galaxies, stars, and planets, the universe has undergone a multitude of changes over billions of years. In this article, we will explore the formation and evolution of the universe. The Big Bang. The current scientific consensus is that the universe began with the Big Bang approximately 13.8 billion years ago. At the moment of the Big Bang, the the universe was incredibly hot and dense, and it rapidly expanded and cooled over time. As the universe cooled, subatomic particles such as protons, neutrons, and electrons began to form. The formation of atoms. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form. These atoms consisted mostly of hydrogen and helium, the two lightest elements in the periodic table. The formation of atoms allowed the universe to become transparent to light, and the cosmic microwave background radiation that we observe today was emitted at this time. The formation of galaxies. Over time, the universe continued to expand, and the first galaxies began to form. The earliest galaxies were small and irregular in shape, but as they grew and merged with other galaxies, they became larger and more organized. Galaxies come in many different shapes and sizes, from spiral galaxies like our Milky Way to elliptical galaxies. The formation of stars and planets. Within galaxies, stars form from clouds of gas and dust. As these clouds collapse under gravity, they become hotter and denser until nuclear fusion reactions begin, releasing enormous amounts of energy in the form of light and heat. Planets form around stars from the leftover gas and dust that didn't get incorporated into the star. Planets come in many different sizes and compositions, from small rocky planets like Earth to large gas giants like Jupiter. The fate of the universe. The fate of the universe depends on the amount of matter and energy it contains. If the universe has enough matter, its gravity will eventually slow down the expansion and cause it to collapse back in on itself in a big crunch. If the universe has too little matter, it will continue to expand forever, eventually becoming a cold and dark place. The role of dark matter and dark energy. While we can observe and understand much of the visible matter and energy in the universe, there are still significant gaps in our knowledge. Dark matter and dark energy are two mysterious components of the universe that have yet to be fully understood. Dark matter is a type of matter that does not emit, absorb, or reflect light or any other form of electromagnetic radiation, making it invisible to telescopes. It is estimated to make up around 85% of the matter in the universe, and its gravitational effects can be observed in the movement of stars and galaxies. Dark energy, on the other hand, is a hypothetical form of energy that is thought to be causing the expansion of the universe to accelerate. Like dark matter, it cannot be directly observed, but its effects can be seen in the observed cosmic microwave background radiation and the large-scale structure of the universe. The search for answers. Despite our many advances in understanding the universe, there is still much we do not know. Scientists continue to study the universe using a variety of methods, including observations from ground-based telescopes and satellites, as well as computer simulations and theoretical models. One of the most exciting areas of research in astrophysics is the search for exoplanets, or planets outside of our own solar system. The discovery of thousands of exoplanets in recent years has opened up new avenues for exploring the possibilities of life beyond Earth. Another area of active research is the study of gravitational waves, ripples in spacetime caused by the movement of massive objects such as black holes and neutron stars. The detection of gravitational waves in 2015 provided a new tool for studying the universe and opened up new possibilities for observing some of the most violent and energetic events in the cosmos. The future of the universe. As we continue to study the universe, scientists are also trying to understand what the future holds. Based on our current understanding of the universe's expansion and the forces that govern it, there are several possible scenarios for the universe's ultimate fate. One possibility is the Big Freeze, in which the universe continues to expand and cool until all stars burn out and the universe becomes a dark and empty place. Another possibility is the Big Rip, in which the expansion of the universe accelerates to the point where it rips apart galaxies, stars, and even atoms. Yet another possibility is the Big Crunch, in which the universe's expansion eventually slows down and reverses, causing all matter to collapse back into a singularity, much like the Big Bang that started it all. The importance of studying the universe. Studying the universe is not only important for satisfying our innate curiosity and fascination with the cosmos, but it also has practical applications in our everyday lives. For example, studying the movements of celestial objects and the effects of gravity has allowed us to develop accurate models for predicting the behavior of satellites, which are crucial for GPS navigation, weather forecasting, and telecommunications. Studying the universe has also led to many technological innovations, such as the development of fiber optic cables, which use the same principles of light transmission that we observe in the stars. Advances in materials science, computer technology, and many other fields can also be traced back to research in astrophysics. Furthermore, studying the universe can help us to better understand our place in it and our connection to the larger cosmos. It can inspire awe and wonder, and foster a sense of interconnectedness with all living things and the universe itself. The importance of protecting the universe. As we continue to study and explore the universe, it's important to also consider the impact of our actions on the cosmos. The universe is a precious resource that we must work to protect and preserve for future generations. One of the biggest threats to the universe is human activity, such as pollution, deforestation, and climate change. These activities can have a significant impact on the environment and ecosystems of our planet, and they can also have a ripple effect throughout the universe. For example, the proliferation of space debris from satellites and rockets can pose a threat to the space environment and the integrity of space missions. Modern astronomy techniques and tools of observation. Astronomy is the study of celestial objects and phenomena that exist beyond the Earth's atmosphere. For centuries, humans have been observing the night sky, but it wasn't until the development of modern technology that we could fully explore and understand the universe. In this article, we will discuss the modern astronomy techniques and tools of observation. Telescopes. Telescopes are the primary tool used by astronomers to observe the universe. These instruments gather and focus light from distant objects, allowing astronomers to study them in detail. There are two main types of telescopes: refracting and reflecting. Refracting telescopes use lenses to bend and focus light, while reflecting telescopes use mirrors. Both types have their advantages and disadvantages, and astronomers often use a combination of both for their research. Radio telescopes. Radio telescopes are a type of telescope that detects radio waves emitted by objects in space. These telescopes are useful for studying objects that emit little or no visible light, such as black holes, pulsars, and other types of celestial objects. Radio telescopes can also be used to study the structure and composition of the universe. By analyzing the frequency and intensity of radio waves emitted by different objects, astronomers can learn more about the nature of the universe and its origins. Space telescopes. Space telescopes are telescopes that are launched into space and orbit the Earth. These telescopes are used to observe the universe outside of the Earth's atmosphere, which can interfere with observations. Space telescopes can also observe objects that are too faint or too distant to be observed from Earth. One of the most famous space telescopes is the Hubble Space Telescope, which has been in operation since 1990. The Hubble has made numerous groundbreaking discoveries, such as determining the age of the universe and discovering new galaxies. Spectroscopy. Spectroscopy is a technique used by astronomers to analyze the light emitted or absorbed by objects in space. By analyzing the spectrum of light emitted by an object, astronomers can determine its composition, temperature, and other physical properties. Spectroscopy is an important tool for studying the universe, as it allows astronomers to learn more about the nature of celestial objects and the processes that occur within them. Gravitational wave detectors. Gravitational wave detectors are instruments that detect gravitational waves, which are ripples in spacetime caused by massive objects, such as black holes or neutron stars, colliding with each other. The first detection of gravitational waves was made in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. Since then, several other gravitational wave detectors have been built around the world. Interferometry. Interferometry is a technique used to combine the signals from multiple telescopes to create a single, high-resolution image. This technique allows astronomers to observe celestial objects with greater detail and precision than is possible with a single telescope. One example of interferometry in action is the Event Horizon Telescope, ETH, a network of radio telescopes around the world that is used to create images of black holes. In 2019, the ETH made headlines when it released the first-ever image of a black hole, providing a glimpse into one of the most mysterious and enigmatic objects in the universe. Computational astronomy. Computational astronomy is a rapidly growing field that involves using computer simulations and data analysis to study the universe. With the vast amounts of data now available from telescopes and other instruments, computational methods have become essential for analyzing and interpreting this data. One example of computational astronomy in action is the study of galaxy formation and evolution. Using computer simulations, astronomers can model the formation and evolution of galaxies over billions of years, providing insight into the processes that shape the universe on a large scale. Artificial intelligence. Artificial intelligence, AI, is another tool that is increasingly being used in astronomy. With its ability to analyze large datasets quickly and efficiently, AI is being used to identify and classify objects in the universe, such as galaxies and supernovae. One example of AI in action is the use of machine learning algorithms to analyze data from the Large Synoptic Survey Telescope, LSST, a telescope that will begin operation in 2023. The LSST will generate a massive amount of data, and AI will be essential for analyzing this data and making new discoveries. Astrobiology. Astrobiology is a multidisciplinary field that combines astronomy, biology, chemistry, and other sciences to study the possibility of life beyond Earth. Astrobiologists use a variety of tools and techniques to search for signs of life in the universe, such as looking for biosignatures, which are indicators of life that can be detected remotely. One example of astrobiology in action is the study of exoplanets, which are planets orbiting stars other than our Sun. By analyzing the atmospheres of exoplanets, astrobiologists can search for biosignatures such as oxygen, methane, and other gases that may be produced by living organisms. Astrobiology also involves the study of extremophiles, organisms that can survive in extreme environments on Earth such as deep-sea vents, polar regions, and deserts. By studying these organisms, astrobiologists can learn more about the limits of life and the conditions under which life can exist in the universe. Data sharing and collaboration. With the amount of data generated by modern astronomy techniques and tools of observation, collaboration and data sharing have become essential for making new discoveries and advancing our understanding of the universe. Astronomers from around the world now collaborate on large-scale projects such as the LSST, the ETH, and the Gaia mission, which is mapping the positions and movements of stars in the Milky Way galaxy. Data sharing and collaboration also help to ensure that scientific findings are reproducible and transparent. Many scientific journals now require researchers to make their data and analysis code publicly available, allowing other scientists to verify their results and build upon their work. Dark matter and dark energy. In recent years, there has been an explosion in the number of celestial objects that have been discovered at great distances from Earth. These discoveries have been made possible by advances in technology and the development of new techniques for searching the sky. One of the most important tools for searching for distant celestial objects is the telescope. Telescopes have been used for centuries to observe the stars and planets in our own solar system. However, modern telescopes are far more powerful and can detect objects that are much farther away. Another important tool for searching for distant celestial objects is the use of satellites and spacecraft. These devices can be used to search for objects in the visible light spectrum, as well as in other wavelengths such as X-rays and radio waves. One of the most exciting recent discoveries in the search for distant celestial objects has been the discovery of exoplanets. Exoplanets are planets that orbit stars outside of our own solar system. These planets are incredibly difficult to detect, as they are often much smaller than the stars they orbit and are located at great distances from Earth. However, astronomers have developed new techniques for detecting these planets, such as observing the gravitational effects they have on their parent stars. Another recent discovery has been the detection of black holes. Black holes are incredibly dense objects that are formed when massive stars collapse. They are incredibly difficult to detect, as they do not emit any light themselves. However, astronomers have been able to detect black holes by observing the effects they have on nearby objects, such as stars and gas clouds. Another important recent discovery has been the detection of gravitational waves. Gravitational waves are ripples in the fabric of spacetime that are created when two massive objects collide. These waves are incredibly difficult to detect, as they are extremely faint. However, scientists have developed new techniques for detecting these waves, such as using incredibly precise instruments that can measure changes in distance on the scale of a billionth of a meter. Some of the most exciting future discoveries in the search for distant celestial objects may come from the use of new technology and instruments, such as the James Webb Space Telescope. This telescope, which is set to launch in 2021, will be able to observe the universe in unprecedented detail and may help us to better understand the origins of the universe and the nature of dark matter and dark energy. Another area of research that may lead to exciting new discoveries is the study of exomoons. These are moons that orbit planets outside of our own solar system. Although no exomoons have been directly observed yet, scientists believe that they could exist and may be able to support life. In addition to new discoveries, the search for distant celestial objects is also important for understanding the evolution of the universe and our place in it. By studying the objects and phenomena that exist at great distances from Earth, we can gain insights into the fundamental laws of physics and the forces that shape our universe. However, the search for distant celestial objects also presents significant challenges. For example, the vast distances involved mean that it can take many years or even decades to receive data from probes or spacecraft. In addition, the objects themselves may be incredibly faint or difficult to detect, requiring scientists to develop new and innovative techniques for observation and analysis. One area where the search for distant celestial objects has the potential to make a significant impact is in the search for extraterrestrial life. By studying exoplanets and their moons, scientists hope to identify planets that may be able to support life, and even detect signs of life itself. For example, the study of exoplanet atmospheres has revealed the presence of water vapor and other organic molecules, which are important building blocks of life as we know it. In the future, new instruments such as the extremely large telescope may be able to directly image exoplanets and their atmospheres, allowing scientists to search for signs of life in a more direct way. Another area where the search for distant celestial objects is important is in understanding the evolution of galaxies. By studying distant galaxies, scientists can learn about how they formed and evolved over time, and how they are connected to the larger structure of the universe. The search for distant celestial objects is also important for protecting our planet from potential threats from space. By studying near-Earth asteroids and comets, scientists can better understand their orbits and trajectories, and potentially identify objects that may pose a danger to Earth in the future. Another area where the search for distant celestial objects can be applied is in the study of the early universe. By observing the most distant objects in the universe, such as quasars and gamma-ray bursts, astronomers can look back in time to the earliest stages of the universe's evolution. This can provide important insights into the formation of the first galaxies and the origins of cosmic structure. The search for distant celestial objects also has important implications for our understanding of fundamental physics. For example, the observation of gravitational waves from merging black holes and neutron stars has confirmed predictions of Einstein's theory of general relativity and opened up new avenues for studying the nature of gravity. The search for distant celestial objects has important implications for our human quest to explore and colonize space. By identifying and studying objects such as exoplanets, we can learn about the potential habitability of other worlds and begin to plan for future human exploration beyond our own solar system. Another exciting area of research in the search for distant celestial objects is the study of dark matter and dark energy. These two mysterious entities are thought to make up the majority of the mass and energy in the universe, yet their nature remains largely unknown. By studying the gravitational effects of these invisible substances on visible matter, scientists can learn more about their properties and potentially unlock some of the biggest mysteries of the universe. Furthermore, the search for distant celestial objects has practical applications in fields such as astronomy, aerospace engineering, and even medicine. For example, the technology used to detect and study celestial objects can be applied to medical imaging and diagnosis. And the study of microgravity environments in space can provide insights into the human body and help develop new treatments for various medical conditions. One of the most exciting developments in the search for distant celestial objects is the potential for detecting signals from extraterrestrial civilizations. The search for intelligent life beyond Earth has been a long-standing fascination for scientists and the public alike. And recent advances in technology have made this search more promising than ever before. One approach to the search for extraterrestrial intelligence, SETI, involves looking for signals from other civilizations in the universe. This could include radio signals, laser transmissions, or other forms of communication that might be detectable from Earth.
The Hertzsprung-Russell diagram, also known as the hour diagram, is a powerful tool used by astronomers to classify stars based on their spectral characteristics and their luminosity. This diagram is named after Danish astronomer Ejner Hertzsprung and American astronomer Henry Norris Russell, who independently developed it in the early 1900s. The hour diagram is a graph that plots the absolute magnitude, luminosity, of stars against their spectral type or temperature. The temperature of a star is determined by analyzing its spectrum, which shows the wavelengths of light that are emitted or absorbed by the star. The spectral type of a star is typically given by a letter, with O being the hottest and M being the coolest. The hour diagram reveals that most stars fall into a narrow band that runs diagonally from the upper left to the lower right. This band is known as the main sequence, and it includes the vast majority of stars, including our Sun. The main sequence is a result of the balance between two opposing forces, the gravitational force that pulls the star inward, and the pressure from the fusion reactions in the star's core that pushes outward. Stars that are more massive than the Sun are hotter and brighter than main sequence stars, and they occupy the upper left portion of the hour diagram. These stars are often called giants or supergiants, and they have already exhausted the fuel in their cores that powers their fusion reactions. As a result, they have expanded and cooled, becoming much larger and more luminous than main sequence stars. On the other hand, stars that are less massive than the Sun are cooler and dimmer than main sequence stars, and they occupy the lower right portion of the hour diagram. These stars are often called dwarfs, and they have not yet exhausted the fuel in their cores. As a result, they are smaller and less luminous than main sequence stars. The hour diagram is not only a tool for classifying stars, but it also provides insight into the evolution of stars. By analyzing the position of a star on the diagram, astronomers can determine its age and predict its future evolution. For example, a star that is currently on the main sequence will eventually run out of fuel and evolve into a giant or supergiant. In addition to main sequence stars, giants, and dwarfs, there are other types of stars that can be identified on the hour diagram. For example, white dwarfs, which are the remnants of low-mass stars, can be found in the lower left portion of the diagram. These stars are extremely hot but very small, and they have exhausted all of their nuclear fuel. Another type of star that can be found on the hour diagram is the variable star. These stars change in brightness over time, and they can be identified by their location on the diagram. For example, Cepheid variables, which pulsate regularly and have a period that is related to their luminosity, can be found in a specific region of the diagram known as the instability strip. The hour diagram is not static and can change over time as new observations are made and new theories are developed. For example, recent studies have shown that there may be additional bands on the diagram that correspond to different phases in a star's evolution. Additionally, the hour diagram can be used to study not only individual stars but also entire populations of stars, such as those in globular clusters or galaxies. The hour diagram has also been instrumental in the search for habitable exoplanets. By studying the properties of stars, astronomers can determine the habitable zone around a star, which is the region where liquid water can exist on the surface of a planet. The habitable zone is determined by the star's temperature, luminosity, and size, which can all be determined using the hour diagram. In addition to its scientific uses, the hour diagram is also a beautiful representation of the diversity of stars in the universe. The diagram shows the wide range of temperatures, sizes, and luminosities that stars can have, and it provides a way to visualize the vastness and complexity of the cosmos. The development of the hour diagram marked a turning point in astronomy and has had a profound impact on our understanding of the universe. It has allowed us to classify stars based on their properties and to study their evolution, providing insights into the formation of galaxies and the structure of the universe. The hour diagram remains a crucial tool for astronomers today, and it is likely to continue to play an important role in our understanding of the cosmos for many years to come. As technology advances, astronomers are able to collect more precise data and create more detailed hour diagrams. For example, the Gaia mission, launched by the European Space Agency in 2013, is creating a three-dimensional map of the Milky Way that includes precise measurements of the positions, distances, and motions of more than 1 billion stars. This data will allow astronomers to create an even more detailed hour diagram that includes stars beyond our own galaxy. Furthermore, the hour diagram has implications beyond astronomy. It has been used as a teaching tool to introduce students to the properties of stars and the basics of astrophysics. The diagram has also been used in fields such as geology and ecology, where scientists use similar diagrams to classify rocks and ecosystems based on their properties. Moreover, the hour diagram has also been used to study the chemical evolution of the universe. By analyzing the properties of stars in different regions of the diagram, astronomers can determine the chemical composition of stars and the history of element formation in the universe. For example, the hour diagram can be used to study the properties of metal-poor stars, which are thought to have formed in the early universe before the first generation of stars had time to produce heavy elements. The hour diagram has also been used to study the properties of binary stars, which are two stars that orbit around a common center of mass. Binary stars are important because they allow astronomers to measure the masses of stars, which is difficult to do for individual stars. By studying binary stars on the hour diagram, astronomers can determine the masses, radii, and other properties of stars with high precision. In addition to binary stars, the hour diagram has also been used to study multiple star systems, which are systems with 3 or more stars. These systems are more common than previously thought, and they can have complex dynamics that are difficult to understand. By analyzing the properties of stars in multiple systems on the hour diagram, astronomers can gain insights into the formation and evolution of these systems. One of the exciting areas of research that is currently being pursued with the hour diagram is the study of star clusters. Star clusters are groups of stars that formed at the same time from the same cloud of gas and dust. By analyzing the properties of stars in a cluster on the hour diagram, astronomers can determine the age of the cluster and the rate at which stars are evolving within it. In addition to age determination, the hour diagram can be used to study the process of star formation within a cluster. For example, recent studies have shown that the distribution of stars on the hour diagram within a cluster can provide clues about the initial mass function of the cluster, which describes the distribution of masses of the stars that formed within it. Another exciting area of research is the use of the hour diagram to study the properties of stars in different galaxies. By comparing the properties of stars in different galaxies on the hour diagram, astronomers can study the evolution of galaxies and the processes that govern the formation of stars within them.
The universe is a vast and complex system that has a profound impact on life on Earth. From gravitational forces to cosmic radiation, there are many ways in which cosmic anomalies and phenomena can affect life on our planet. In this article, we will explore the various ways in which cosmic defects can impact life on Earth. One of the most well-known cosmic phenomena that affects life on Earth is the magnetic field. The Earth's magnetic field is created by the motion of molten iron in the planet's core. This magnetic field protects life on Earth from the harmful effects of the solar wind, a stream of charged particles that flows from the Sun. Without this protective magnetic field, the solar wind would strip away our atmosphere and expose life on Earth to deadly levels of radiation. Another cosmic defect that can impact life on Earth is the asteroid impact. Asteroids are large rocks that orbit the Sun and occasionally collide with planets. When an asteroid collides with Earth, it can cause widespread devastation, triggering earthquakes, tsunamis, and even global cooling. The most famous example of an asteroid impact is the one that is believed to have wiped out the dinosaurs 66 million years ago. Cosmic radiation is another factor that can impact life on Earth. Cosmic rays are high-energy particles that come from outer space. These particles can cause mutations in DNA and increase the risk of cancer. However, the Earth's atmosphere and magnetic field provide some protection against cosmic radiation, and most of the harmful particles are absorbed before they reach the surface. Gamma-ray bursts are another cosmic defect that can have a devastating impact on life on Earth. Gamma-ray bursts are powerful explosions that occur when a massive star collapses or when two neutron stars merge. These explosions release huge amounts of energy in the form of gamma rays, which can be deadly to life on Earth. However, these bursts are relatively rare and are not believed to pose a significant threat to life on our planet. The universe is a complex and diverse system, and it has a profound impact on life on Earth. From the gravitational forces of other planets and stars to cosmic radiation and anomalies, there are numerous ways in which cosmic defects can impact life on our planet. In this article, we will explore some of the significant ways in which cosmic defects can impact life on Earth. The first and perhaps most well-known cosmic defect that affects life on Earth is the magnetic field. The Earth's magnetic field is generated by the motion of molten iron in the planet's core. This magnetic field protects our planet from the harmful effects of the solar wind, a stream of charged particles that flows from the Sun. Without this protective magnetic field, the solar wind would strip away our atmosphere and expose life on Earth to deadly levels of radiation. Thus, the magnetic field is a crucial component for the survival of life on Earth. Another cosmic defect that can impact life on Earth is the asteroid impact. Asteroids are large rocks that orbit the Sun and occasionally collide with planets. When an asteroid collides with Earth, it can cause widespread devastation, triggering earthquakes, tsunamis, and even global cooling. The most famous example of an asteroid impact is the one that is believed to have wiped out the dinosaurs 66 million years ago. Although the probability of such a catastrophic event occurring is low, it is still important to continue studying asteroids and their orbits to ensure that we are prepared for any potential impact. Cosmic radiation is another factor that can impact life on Earth. Cosmic rays are high-energy particles that come from outer space. These particles can cause mutations in DNA and increase the risk of cancer. However, the Earth's atmosphere and magnetic field provide some protection against cosmic radiation, and most of the harmful particles are absorbed before they reach the surface. Despite this, astronauts and those who work in space are at a higher risk of exposure to cosmic radiation, which can lead to various health problems. Gamma ray bursts are another cosmic defect that can have a devastating impact on life on Earth. Gamma ray bursts are powerful explosions that occur when a massive star collapses or when two neutron stars merge. These explosions release huge amounts of energy in the form of gamma rays, which can be deadly to life on Earth. However, these bursts are relatively rare and are not believed to pose a significant threat to life on our planet. Besides these defects, there are other factors that affect life on Earth as well. For instance, the position of our planet in the solar system is critical to the development and evolution of life. If our planet were too close to the Sun or too far away, life as we know it would not exist. The presence of the Moon, the tilt of the Earth's axis, and the distribution of water and land also play critical roles in shaping life on our planet. The impact of cosmic defects on life on Earth is a topic that has fascinated scientists and researchers for centuries. In addition to the well-known cosmic phenomena discussed earlier, there are other ways in which cosmic defects can impact life on Earth. One of the less well-known cosmic defects is the impact of space weather on our planet. Space weather is a term used to describe the changes in the environment surrounding Earth that are caused by solar flares and coronal mass ejections. These phenomena release charged particles that can interfere with communications satellites, power grids, and navigation systems. These disruptions can cause significant economic damage and even put lives at risk in certain situations. Another cosmic defect that can impact life on Earth is the presence of black holes. Black holes are regions in space where the gravitational pull is so strong that nothing can escape, including light. Although black holes are fascinating to study, they can pose a danger to life on Earth if they are too close. A black hole's gravitational pull can disrupt the orbits of nearby planets, which can have catastrophic consequences for life on those planets. The impact of supernovae on life on Earth is another fascinating topic. Supernovae are massive explosions that occur when a star runs out of fuel and collapses. These explosions can release huge amounts of energy and can produce heavy elements that are essential for life. However, if a supernova were to occur too close to Earth, it could cause significant damage and even lead to mass extinctions. The impact of cosmic rays on the Earth's climate is an area of growing research.